My next proof here, given that this is a parallelogram and that these two lines are parallel, prove these two congruent. What I'm going to do is, using the parallelogram, I'm going to grab these two sides. Using these two parallel lines, I'm going to grab those two angles. And then using, what else am I going to use? And then using the parallelogram, parallel lines, I'm going to grab these two angles. And that'll give me AAS, congruent triangles, and then I can CPCTC the two sides that I want. So I'm going to CPCTC the congruent sides from these two triangles as they lay there. Here we go. So the first one, I'm going to say parallelogram RSTU, terrible parallelogram. That's given. And I'm going to get everything that I want from it before I start my next given. So I'm going to say that RS is congruent to UT if parallelogram, opposite sides congruent. And then I'm also going to get my parallel lines while I'm at it. So I'm going to say RS is parallel to UT if parallelogram, opposite sides parallel. And while I've got this, I'm going to grab those angles that I want. So angle SRT is congruent to angle UTR. If lines parallel, opposite interior angles congruent. So now I've got one side, one angle. All I need now is using that second given. I'm going to slap out these two to be congruent. So using my second given here, I'll have SV is parallel to UW. That's going to be given. I'm going to grab that second angle. So angle UWT is congruent to angle SVW. If lines are parallel, opposite interior angles congruent. And then I'm going to get my two triangles to be congruent. So triangle UWT is congruent to triangle SVW. And that's AAS. Here's one angle, here's my other angle, and there's my side. And then once I have that, I can grab what I wanted in the first place. SV is congruent to UW, CPCTC. Again, lots of different ways to do that one. That is the way that I thought about it. This one, I'm not gonna lie to you. I thought of a long and frustrating way. You may have thought of a better way, but it's just the way that I thought about it. What I'm gonna do is I've got these two are given as congruent. I'm going to make that 1 and 2 will now be congruent. 2 and 4 were given are congruent. And 1 and 3 given as congruent. Since this is, what else? Alright, well here we go. I'm going to use 1 and 4 to make these two lines parallel. That's going to give me angle 5 right here. Once I have angle 5, I've got two base of a trapezoid. And that makes this an isosceles trapezoid. The two base angles are congruent. That means these two sides are congruent. I'm going to walk that over. And then I'm going to use angle 3 and angle 2 to make these two lines parallel. And so I've got one side that will be, again, walk that congruency over. One side that is congruent and parallel, thus parallelogram. Here we go. It could get involved. Might have more than one column. More importantly, I'm going to use this last when I get my sides ready to go. So I'm going to say angle 1 is congruent to angle 4. Oh, angle 1 is congruent to angle 3. That's going to be given. Angle 2 is congruent to angle 4. That's also given. I'm going to have to use my sides because I used it for the isosceles triangle. So I'm going to say BE is congruent to BC, also given. And that makes angle 1 congruent to angle 2 if sides congruent in triangle, angles opposite sides also congruent. We get all that? Excellent. So that's angle 1 and angle 2 congruent, and that's going to make Angle 1 is now congruent to angle 4, transitive property. So now I'm going to make 1, 3. I got to get the parallel lines now. So I'm going to say that AB is parallel to D. I actually didn't need this, did I? We'll talk about that later. DC. If alternate interior is congruent, angles congruent, then lines parallel. That makes angle 1 congruent, or angle 3 rather, congruent to angle 5. If lines parallel, alternate interior angles congruent. And now I've got angle 5 congruent to angle 4. And that's going to allow me to call this an isosceles trapezoid. So angle 5 congruent to angle 4 is going to be transitive. And then I'm going to say that ABED is isosceles trapezoid if base angle is congruent then it's an isosceles trapezoid. Because I've already got one side parallel, and I've got a pair now of base angles. So the parallel sides, one set of parallel sides, exactly one set of parallel sides is what makes it a trapezoid, and then the base angles being congruent is what makes it an isosceles trapezoid. Once I have that, I'm going to go over here. Once I have that, I'm going to grab AD. AD is now congruent. How much time am I looking at? Plenty of time. AD is congruent to BE. If it's an isosceles trapezoid, then my side's congruent. These are sides, these are bases. More importantly, now the last thing I need is for these sides to be parallel. I already have them congruent. Oh, I need to transitive that over. I'll have AD is congruent to BC. Way back in the beginning, we have AB and DC together. AB and BC rather. AB and BC, oh man, that's the parallel. Here we go. BE and BC are given as congruent. I just proved with my isosceles trapezoid that these two. So I'm going to transitive over to that third side. So now I have these two sides congruent. All I need them to be is parallel now. Angle 3 is congruent to angle 2. That's another transitive. That's going to make AD parallel to BC. If corresponding angles congruent, then lines are parallel. There we go. And my last one, ABCD is parallelogram. If opposite sides are parallel and congruent, parallel and congruent, then trapezoid, or then parallelogram. And that was long and involved. There's probably a shorter way. I could not think of it. All right, next proof. We'll start it on the next video.